Hi, this is me, Mustafa. Yes, I'm your course coordinator. Okay, so today is about Chapter 6. We already discussed Chapter 6 and talked about Chapter 6 in the last 2 weeks. But I promised you that I'm going to record a video just to highlight some of the important parts in this chapter. So first of this chapter is about network layer, and network layer do the following: address, device encapsulation, routing, de-encapsulation. These are the important parts in this chapter. Okay, I'm going to skip the beginning, the first part of this chapter, because we were discussed it, but one of the important things in this chapter is let me just select laser pointer. Okay, that the IP protocol is connectionless and it is unreliable. It means there is no guaranteed delivery or acknowledgement and media independent. I'm going to skip this part because we already talked about it. Remember, this is very important that you know every part in the IPv4 packet header. So try to Google it. It is a good idea to go to Google on the website and search for these like what is the version, time to live, protocol, source IP, destination IP. Also, it is a good idea to visit Cisco Network Academy website that I'm usually always actually asking you to do that, and I hope you are checking this website. See, this is the website. Let's go to the first part. I'm going to show you. This is the first part. Yeah, where it is introduction, network, routing table. No, not routing table. Yeah, and the introduction. Yes, you can see here. If you see, like, this is the version. For example, here is the definition of version. What is responsible for defensive service. It's very important for the quality of service. Time to live. What is time to live? We already discussed these concepts in the lecture, but I really encourage you to visit the website. This website, as remember, this website is considered as your textbooks for this course. Yeah, let's continue. Okay, simple header, IPv4 header. I promised some of you that I'm going to show you live how to capture data using the Wireshark. Now, of course, you know that this is Wireshark, and in this figure, as you can see, simple IPv4 header, what is happening that it's capturing one of the headers for IPv4 header. And here, if you click on the Internet Protocol version, which is the header of IPv4, you can see different fields in real life. I'm going to try to show you something. Let me open. This is my Wireshark. Let me start capturing. I'm now on Ethernet interface. I'm selecting the Ethernet interface and click on Start. Now let's start capturing. As you can see, there's a lot of things coming in or out from my PC, and I'm surprising what's happening. Yeah, maybe someone's hacking my PC at this moment. Oh yeah, no. This is all because of the Dropbox. Dropbox is doing some synchronization. Now let's look for HTTP something, or yeah, like for example, this is HTTP. Yeah, that's great. This is HTTP. Now look at this. This message. Now this message, as you can see from here, it's have been sent. Let me stop. Yeah, I just stop it, and let me right click on the message, follow stream, TCP stream. When I click on follow TCP stream, it's going to show me the stream of TCP from the handshake till termination, if it is there is the termination, or if it is inactive. Yeah, this is stream content. What is content? This is something about, I don't know what it is. Anyway, it is something with HTTP. Sorry, it's not showing me the TCP connection, just showing me the stream of the HTTP. Anyway, HTTP is based on IP protocol, so it's good. Here you can see was the frame and Ethernet. These both fields are belonging to the data access layer, the down layer. In the Ethernet field, what you can see the MAC address for the source and destination. This is this is the destination. My PC is the destination. So this packet is because I'm using this Fujitsu. Let me just check. This is source. Yeah. This is source. Yeah. See, my PC in this case is the destination. It's have been sent from something called primary A. Probably this is the router MAC address, and the destination is my PC because I'm using actually Samsung laptop, but probably Samsung laptop have network card from Fujitsu. So this is my MAC address, which is the destination MAC address. And here what you can see is the internet protocol. This is what interesting us. Now here internet protocol version, let me just minimize it. This part is the IP header, IPv4 header. So if I'm going to expand this header, I'm going to see all the fields. Let me do this. Let me show you something. I'm going to minimize this. Let me click, go back. Yeah, see, this is the header. Okay, this is the header. I'm going to show you the fields. So, yep. Let me make it bigger. Look here. I just expand this IP protocol version 4. As you can see, first part is version. And this is the value that we have in the version. 4 because it is IPv4. It will be 6 if I'm using IPv6. This is the header length. Here is the header length. It's 20 bytes. It's standard. There is no option or any external thing. Now, here what you can see is the DS and DSCPECN value. As you can see, I'm going to expand it. Let's see. This is the DSCD, and here what we can see is ECN. This is ECN, explicit congestion notification. The value is 0. Everything here is 0, so it is normal payload. Now the second part is the total length. Third part actually is 219. This is the total length for the whole packet. Identification, this is the identification value. Flags, this is the flags. Let's expand the flag. See these 3 bits are the flag. What do we have? Reserve bit, not active. Don't fragment set. This means we are not allowed to fragmenting or dividing this packet into small. Fragment offset, time to live is 62. Protocol is using TCP. This is protocol, the value is 6 because we are using TCP. Header checksum value. Okay, and we have source IP address. It is 108.1 blah 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 something from the internet, and this is the destination. Source geo IP unknown, destination geo IP unknown. This is geographical location of the IP, it is unknown. So anyway, see how beautiful this is the header. Option, we don't have option in this one. So this is the header. Try to do it by yourself. Install Wireshark. Again, Wireshark, it is free, as you know, and it is available on the internet. You can easily get it, and of course you have internet. Play with it, see what's happening. So this is the sample header. Now IPv4 have limitation. We discussed it. These are some of the solutions that have been introduced in IPv6. comparison between IPv4 and IPv6. We discussed that. I'm going to skip it. I don't have IPv6 network here to make any demonstration. Now we discussed the router, how it is important in making the decisions. Now router I think most of you have if you have internet at your home, then you have router, but usually the router that you have, not like this, is like a small modem, D-Link or Huawei, that's providing by Omantel for internet. But the router is router, no matter what, how it looks like, how big it's. The main job here in this router is to introduce default gateway for your network. Now this is your network. Have like a small network, home network. You have PC1, PC2, and you have network address. This is your network address, and your default gateway is going to be this point. So in this case, I'm going to ask you a question. What is the default gateway in this case? The IP address of the default gateway. You can pause a little bit the recording and answer this question. Anyway, this is the IP address of the default gateway. .1. Because this is the one, and this is the network address of our network. Anyway, what do we have here? First of all, before starting go deeper in the concept of routing and decision making in IPv4 and IPv6, what I want to discuss first of all is not only the router who's making the decision of the routing. By the way, router have two jobs. One of the jobs of the router is to provide connectivity or bridge between the internet and your local network, and it is responsible for not network address translation, but the most important things of the router or job is forwarding. This means the router received a message from your network and its job to forward it to another location. Now in this example, it is very simple because it have only two connections, but some routers have more than one connections, have 3, 4, 5 connections, maybe more. So making the decision about where to forward the message that it is leaving your network and going to the internet is very important things to do for the router. Now, but not only the router who's responsible for making the decisions, it's also PCs making a decision. Like here what you can see, this is the routing table for the PC. We discussed the concept of routing table. Routing table helping the device, whether it is a PC or router, to make a decision. It's like you. Now, if you remember what we talked in the lecture, that the first time when you arrived at Sohar University, for example, I'm sure you didn't know where was the canteen or the cafeteria, because you're new to the university, you don't know where's the building. So you had to ask someone to know where's the cafeteria. Now you know that there is 2 cafeterias in the campus, or 3. In order, if you feel hungry at the middle of the day, and this is what you usually do at my lecture anyway, what you're going to do, how you make a decision about where to go to which cafeteria? You have 3 locations. You need to make your decision maybe according to the distance, but not always the case, because sometimes there is other factors. Okay, so the same thing is happening in the PC and in the router. Now let's imagine that this PC have 2 interfaces. One of them is wireless and the other is Ethernet. Now you want to send a packet, a data, email, let's say. Now your computer need to make a decision where to send this packet. Should the PC send it to the wireless network, or should the PC send it to the Ethernet? It is going to send it to the Ethernet. Should it send it to another PC in the Ethernet network, or to the default gateway that you have? Okay, so making the decision is even a human, to make a decision, they need information. Like for you, to making a decision where you are going to eat in the afternoon, the university, you need to know how the campuses look like. You need to know the distance, for example, from your location to each of the locations here, and then you make a decision. Now the computer needs something like this. They use something called routing table for that. We are now talking about the PC. We didn't start talking about the router. Now if you type this command, I'm going to show it to you live. Open command prompt. Yeah, this is the command prompt. I'm going to write net state -r. Now this is the routing table of my PC. Any PC, any Windows PC have, if you type the same instruction, you will get the same thing. Look at here, this is the table. But let's consider this one. What do we have? We have different entries. The PC have first entry here. Now let me go to the next slide. This is much more better. Yeah. Like, look at this entry. This is the default gateway. It's mean that the PC, if when we have 00000, it's mean anything that, let's return back to this slide. Yeah. It's mean that the PC, this is internet. The PC, if it is for any destination that it is not in the network, in the local area network, is going to send it to the default gateway, because default gateway is the only exit from our network. As a stub network, this is stub network. It means the network at the end. There is no other exit from this network unless it's the interface on the router. So the first entry is showing that for everything, 00 means for everything. Use the gateway, and this is the gateway, 192.168.10.1, which is the IP address of the default gateway, which is the router. And use this interface. So it's this interface. The routing table, we must mention the interface, because sometimes there is more than one interface. Like in this example, there is a wireless interface that have different IP address. So the PC need to mention which interface is going to be used as exit. And here is the matrix. The matrix is very important factor. It's showing when the matrix is lower, it means better. Just in case if there is the two interface that can send to the same network, or two routes that can eventually deliver the packet to the same network. So in this case, metric will be the final factor that is going to decide which interface is going to be used. Now this entry here, we have it here, it is for local loop. We have study local loop. It means it is internal. Like you have local website inside your PC and you want to send a packet to it, so you are going to use one of these IPs. The third part here is, it's all start with the 192.168.10. It's mean they are values of the local network. Let me just, yeah, it's mean they are values of, sorry, not this. Let me delete it. Yeah, we have these. Now see, these are the values of the local network, because the local network here is have the same IP address. It is 192.168.10. So first one is anything within our network. Like for example, this PC. Let's say this PC here have the IP address of 192.168.10.5, for example. This is the PC. So what's going to happen? The computer wants to send a packet to this destination IP address. What the computer is going to do? First of all, the computer is going to look in the internal routing table about some entry that have the value similar to this or near to this value. It's looking here, 000. Of course, if we didn't find anything, we will go to 00. 127, no. 192. Yes, this looks similar. Let's go to the second value. It is 168. It's okay. It is the same value now. 10. Yes, it is the same. Do we have 5? No, we don't have 5. So we will take 0 because it is the first entry. In this case, the PC is going to follow this route in sending the packet. Now, in this route, the gateway, it is on link. It means it is local. So there is no gateway. What's trying to say here is there is no default gateway. It is something within our network. And the interface is 10.10. So this is the interface. Then immediately the PC is going to send this packet to the local network, to the switch, and the switch will deliver it to the PC. Now these values are for multicast and these values for broadcast. Now what if the PCs decide to send something, a message for example, an application want to send a message to, let's say, network address of 200.1.1.1. What is going to happen? The PC is going to look in the routing table, look for entry that start with 200. If there is an entry that starts with 200, no. Therefore, it's going to send it to 000. It's going to use this route as a default route. Then the PC is going to send it to the default gateway, and the default gateway, the router, is responsible for forwarding this message to the final destination. Now, router packet forwarding decision. How the router is making a decision about forwarding the packets. Look at this example here. What do we have? We have a router. This is R1, and R1 is connecting to two networks. This is directly connected network, and we have another directly connected network, and we have third connected network. Now, usually the router can immediately identify and know the directly connected network with its network address. But the router needs help from another one to know about the remote networks, which we have two networks. Network 10.1.1.0 and network 10.1.2.0. Now, router don't need anything to identify the directly connected networks. It can immediately, because they are connected directly to the interfaces on the router, so this is no problem. But for remote networks like these two networks, it needs routing protocol for that. Routing protocols. Routing protocol, there's a lot of routing protocols. We are going to study it later, like for example EIGRP, OSPF for example. These protocols is used by the router to exchange information. It's like similar example when you sit in the class. Let's say you are sitting in the class watching my lecture, listening to my lecture. What you can do is to know who's sitting on your left and who's sitting on your right. It's no problem. But let's say that you want to know who's sitting beside your friend. One of the way, of course, you can just move your head and see who's sitting there. But let's say hypothetically that you cannot move your head or move your eyes. What you can do, you can ask this fellow about who's sitting to the left of you. He's going to say that, for example, Khamis is sitting there. So you immediately know that Khamis is sitting at this location. Now, this guy, the way that you communicate and asking is the routing protocol. So routers do the same thing. Router exchange information one with another to know about each other neighbors. Now look, this is a beautiful example about IPv4 routing table. Now again, router need to make a decision. If a router received a message from PC1 or PC1 generate a message and it is sent it to the default gateway, which is this interface on the router, then the router received this message. Now the router need to make a decision about where to forward this message, because the router had two options. One option is sending this message this way, and the other option is sending the message this way. So how the router is making the decision? The router, again, needs some information. Like you looking for the cafeteria, you need to know the map. Router is doing that by the help of routing table. There is a routing table, and here is the routing table. Routing table have two sources of information. One source is the local or directly connected network. It's any network that directly connected. Like in this example, there is 3 networks directly connected, which is this one. This is network number 1, network number 2, and network number 3. The second source of getting the information in the routing table is what is routing table information from the neighbor router. Now here this router have 2 networks directly connected, and R2 know everything about these networks, so the R2 and R1 can exchange information, and everyone share information about his neighbor with his neighbor's router. So anyway, this way the router is going to build routing table. Now routing table again is helping the router to make a decision. How the routing table, you can see the routing table. We already discussed the routing table, and probably most of you now know how to read the routing table, but I'm going to briefly go through it again. But before that, let's stay with this example. I want you to study this network. Look at this network. We have 2 routers. We have 5 networks. This is network 1, network 2, network 3, and network 4. And what do we have? In each router we have 3 interfaces. This interface is Giga Ethernet 0.0, and this Ethernet is Giga Ethernet 0.1, and here we have serial interface S000. For this router, it's not mentioned the interface's name, but of course there is an interface's name. Now we are going to examine the routing table of router 1. Now the routing table have again 2 types of routes. Routes for directly connected networks. Routes for directly connected networks, which is, in this example, we are talking about this network, and of course this network. Routes for directly connected network are very simple. First of all, we have part A, which is identify how the network was learned about the route, because the network, the router need to learn about the network. So in this example, C is for connected and L for local. Connected is mean the network. So here, as you can see, is the network address of 192.168.10.0, which is this network. It is directly connected. This is part B. Part B identifying the destination network. We are talking about this destination network. Part C is discussing identification of interface to the router. Which interface is connected to this network? It is interface Giga Ethernet 0.0, which is this one. So again, in this example, let's identify the first route. C is connected, directly connected, which is this network, network 10. And part B, identify the destination network. It is destination network is 192.168.10.0. Which interface? Using Gigabit Ethernet, which we just to make it shorter, we refer from, instead of writing Gigabit Ethernet, we write just G and 0, 0, as we can see here. The second part is local. Actually, this part is not about network, it's about interface, because we're referring to 1. What is 1? 1, it is not clear here. 1 is the IP address, which is this one, 192.168.10.1 is the IP address of the interface, of the local interface in the router. It is also directly connected, and it is the same interface. I know it's look like stupid thing that you write it 2 times, connect the interface and the network, but this is the way that the router is using. There is of course reason for that. I don't want to discuss the reasons now, but just take it as it is. So the other type of network routes is the remote network routing, or in the table entries, the remote network. Remote network is like what? Now this is R1. Again, it is connected to 3 networks, as we mentioned, but there is 2 networks, which is this one and this one. They are remote networks, and also could be like, for example, this one. They are considered as remote networks because they are not directly connected to R1. Now, remote networks route entry is more complicated. Again, we have the first part in the blue, this color, is referring to what? Identification, how the network was learned by the router. Let me select the laser pointer. Now this part, the blue one, or lone Fairuzi, is the identification how network was learned by the router. D, the letter D here, is referred to EIGRP. EIGRP is routing protocol that you are going to study in the future. Don't worry about it. Anyway, so this is second part. The yellow part is identify the destination network. Here we can administrative distance. Administrative distance is about trustworthiness. It's like in your real life. Usually when you hear something, like for example, you open a website, BBC website, and you saw a big title that UFO or aliens from the space have arrived into the earth and make contact with the human. I know it's look like something strange, but you're going to believe it because it is BBC. But if your little brother, who's 4 years old, came in hurry and asked, he just saw UFO and aliens from the space just arrived on the roof of our house, what are you going to do? It's the same thing. It's like BBC have the trustworthiness of 90, your little brother have trustworthiness of like say 200, because you don't trust him, you give him 200. When the number is low, it means it is trustworthy. You trust it. Trust. So lower is better. The second parameter, which is this number, is identify the metric. The metric is like a distance to the remote network. How far is the remote network? Again, lower is better. VIATs mean which interface you are going to use. This is E part. Identify the next hop address to reach to the remote network. And the last part is the how long it has been since the router learned about this route. You could probably find in some old routers like 5 years, 6 years, 10 years route, because 10 years ago the router have been identified about the route. And finally, the exit interface to where to forward the message. Now let's do it in practical. Let's just look at it with the numbers. Look at this. It's referring to this network 10.1.1.1, which is this one. What it's saying that it is trustworthiness of 90 and EIGRP have been used because of this D. It means EIGRP have been used to learn about this network. It means there is EIGRP protocol is running between router 1 and router 2, and they are using this protocol for exchanging the message and route information. C is 19 is usually the administrative distance number for the EIGRP protocol. It is for every EIGRP they have 90. This is the metric. How far is this network? And here we can find the next hop, which is this interface, because it is 209.165.200.224. Instead of 224, put this number 226. So Yep, it is the same. So it's mean this is the next hop. It's mean router 1 should send the packet to this interface for forwarding using serial 000, which is this interface. Okay? Now I want you to spend some time to study this routing table. Go through every route. Try to learn about it. Of course, we're going to talk about it in the practical. Now this is the router part, how to part of the router, and anyway, I'm going to skip it because you can do it by yourself, and some part they need practical. Already Ms. Safia is showing you on the lab the equipment of the router. It is very important. Let's go to practical side today. Yeah, see, there is a beautiful exercise at the website. At the end of this chapter, there is some skill challenge, packet tracer integrated challenge. This is very beautiful exercise that I recommend every one of you to do it. I think you must do it in the lab, but I recommend to practice on it at your home on your personal computer. Look at this exercise. We are going to do it again. Now, in this exercise, there's some cumulative challenges. It means a lot of information from how we say it, a lot. Yeah, there's a lot of things that you can learn from this exercise, and you can test your knowledge in configuring router and switch. See what we must do in this exercise. First of all, you will receive a probably different topology when you open it. It is randomly have 3 different topology. Every time is showing different figure, but you must do the following. First objective, finish the network documentation. Perform basic device configuration on the router and switch, and verify the connectivity. Now this is a scenario that you have something, blah blah blah. Read the scenario. Requirement, provide missing information in the address table. I didn't understand what they mean by name the router college and second switch class B. You will not be able to access class A. Okay, let's see how to do it. First of all, name the router college. Let's go to this router, double click on the router. This is the router, command line interface. Enter. This is the user mode. I'm entering the privilege mode. I write configure terminal, then host name, and write college. Always pay attention to the case sensitive. C is capital letter at the beginning. College. Yeah, I have this have been now changed from 15 to 18. That's good. What else? Let's go through it. Use Cisco as your exe password line, class as a privilege, encrypt all plain text password. Let's do this. So first of all, I need to have privilege. I'm going to do this class as a privilege password. So it's mean enable secret. Enable secret. Secret will be what? Class. What else? Let's go to the line VTY. There is instruction also password about how to encrypt the password. IP password. No. Encrypt. Anyway, I will go back to it later. Line console 0 password Cisco. I'm doing now this step. Cisco login exit. This is, it's mentioned for all lines. It's mean I'm not sure if I have to do it with the VTY. I will do it anyway. Line VTY from 0 to 15. I'm going to use all of them. Password, Cisco, login, exit. I did pay attention. Did they change the numbers? Okay, I miss it. What else? Configure appropriate banner. So I'm going to do this one. What the banner will be. Banner MOTD hash. Hi, this is my router. Write anything. They didn't ask me to write anything special. Now this is the banner. Configure appropriate banner. Configure address for all devices according to the address table. Let's see. This is college. Have to interface. One of them Giga Ethernet. Interface. Giga Ethernet 0-0. I'm working on this one now. I'm working on this one. Enter. IP address. What is the IP address? 128.107.20.1 255.255.255.0. Enter. No shutdown. Usually write description. Always write description. Like let's say this Giga Ethernet 01. Yeah, this is going to interface to switch. I write it in capital letter. Interface to switch class A. Okay, this is the description. Go to the second interface. This is the second interface. I will go right interface. Let's try it. Exit. Interface G0-1. IP address. Let's copy this IP. It's a good idea to copy the IP, but always avoid to copy the instructions, because you will lose the skills of writing fast, and you lose the opportunity for your experience in configuring the router interface. Now this is the interface. No shutdown always is very important. And then write description. Interface to switch class B. Exit. What else it's asking me to do? Configure addressing. Okay. Document the interface with description, including class B VLAN interface. There is a VLAN interface. Okay, this is VLAN 1 and VLAN 2. This is and the switch. Verify connectivity, troubleshoot document. That's it. Let's do, just make sure everything is alright. Show IP interface brief. Now I just forget one of the instructions. It's called IP encryption service, encrypt something. I just missed this one. Encrypt or plain text password. How to do it? Because we still have, if I write show run config, this is the run config. See, this is the secret is encrypted, but I still have this password, and this password is plain text. So how to do it? How to encrypt it? There was a command, but I'm not recalling it. it was about service password encryption. Yes, service password encryption. This command will do the following: encrypt all plain text password. So if I click enter and press Ctrl Z, show, run again, let's see. Yes, it's encrypted. As you can see, all the passwords have been encrypted after typing this command. That's beautiful. Okay, but still 42 anyway. Now do what? Now go, I'm going right copy just to save the configuration, copy, run, start. This command will save the configuration file to start config, just in case if I turn off the router I will not lose the configuration. Now I go to second objective is to do what? Is to configure, name the router and the second switch. You will not be able to access class A. Let's try class A. Why? Okay, I'm not able to do it, so I'm going to this one. Go to the command line interface. Sorry, I have to answer this call. I'm writing enable to move to the privilege mode. Configure terminal. Now what we want to do, I'm going to do all this again. I'm going to configure the password, enable secret class, yeah, what else, line console 0, password Cisco, login, line VTY 015, password Cisco, login. That's great. Let's name the switch. I'm going to name it class B. Hostname class. I think it's case sensitive. Class B. Yeah. What else? I must also do service password encryption. That's great. So name is finished. This finished. This finished. This finished. Banner. I still have to do banner. Banner. MOTD. I can put any. I will write like, for example, hi again. This is also my switch. And we finished the banner. Configure the address for all devices. Like, for example, we have 2 VLAN, so I must create 2 VLAN on the switch. Going to write VLAN. Sorry, 1 VLAN. It's VLAN 1. VLAN 1. Exit. It is already created. Interface. So to configure the IP address for the VLAN, I'm working on this. You must treat the VLAN as interface, but before that, let me show you something. Let's go. I just by mistake press 4 and it's going to load. Okay, I had to pause the recording because it's taking long time for this. But anyway, what we must do now, I was trying to show you the interfaces. Show IP interface brief. See, this is the interfaces on the switch. As you can see, it is start with interface 01. And it is 24 interface for fast Ethernet, and we have 2 Giga Ethernet interface, and this is the physical house look like. But what I want to show you that there is no VLAN interface. But now I'm going to create one. How to create a VLAN interface like this one? VLAN interface, again, it's used only for remote access, for management purpose. So I'm going to the configuration mode, write interface VLAN 1. VLAN, yes, question mark, VLAN number 1. Now if I'm going to enter now this VLAN, the virtual interface VLAN is going to create it. Now this has been just created. I will assign the IP address as shows here. This is the IP address. So I will write IP address. I'm going to assign IP address best 255.255.255.0. That's it. No shutdown. There is no need to write no shutdown, but I like to write it always. Now let's go back and see the interface. Show IP interface brief. Yeah, this is the IP interface brief. Wow, yeah, this is the VLAN. Can you see? This is the new interface, VLAN interface that we have, and it is up. Why it is up? Because all the interfaces, as you can see, show VLAN brief. All the interfaces that we have are in VLAN number 1. Anyway, you didn't study this, but just showing you. Later you will study the VLAN and you will learn a lot about VLAN. For now you don't need to know a lot. Cisco enable class. Copy. I'm going to save what we just done. Start. There's anything else to do? Document interface description include the class VLAN interface. Save your configuration. We didn't make documentation about VLAN, but no problem. Save, verify connectivity. We still have one thing. We have these PCs. We need to configure IP address for each PC. Going to close this. This is student PC. Yeah, this is student PC. My computer is running slow. Okay, desktop IP configuration. Let's see the IP address. Is it correct? Yes, it's the same as this one. What is the default gateway, by the way? See, this is the missing part. The default gateway is the IP address of this router. So in this case is going to be the one that is connecting to Giga 0.0. Let's go to the router. Show IP interface brief. So we have two interfaces, but which one is connected to this network from the IP address? 128.107.20.1. So this is network 20.1, this is 30.1. So the IP address and the default gateway is the IP address of this interface, which is 128.107.20.1. Yeah, we don't have any change here. Yeah, see, so we did something right. They just give us 4 points. Let's go to the second PC. This is desktop. Let's check the IP address 30. It is correct. The default gateway, it is the same, 128.107.20.1. That's nice. Let's go to the third PC. Let's check the IP address. Yeah, it is correct. The default gateway will be 128.107.30.1. Student PC, student 4 PC, the same, because they are on this side and they have the network 128.107.30. So this interface on the switch, or this one, is the default gateway. In this case it is 128 yes .107 dot 20.1 no dot 30. There's something wrong. It is written here, it is 20. It's not supposed to be 20. Yeah, see this. Haha, no, yeah, 20. Yeah, this is supposed to be 30 because I just find it. It is 30, not 20. I'm going to fix it. See, I just find something wrong and we fix it. 1, they become tricky. 95. Now do what? Troubleshoot, implement necessary to identify full end-to-end connectivity. Let's try something like this. Terminal, not terminal. Let's do ping. I'm going to ping PC3. Ping. This is the IP address of PC3. It is 128.107.30.25. Let's see what will happen. Oh, request time. Yeah, okay, it's working. That's good. It's excellent. Let's ping PC4 30. Okay, great. Let's ping PC2 20.25. That's great. .30. Yes. Okay, excellent. There's full connectivity. Why it is 95? Let me check result. Going to crank check result. See here, default gateway and the switch. Yes, I didn't mention the default gateway in the switch. I'm going to configure it. Close this. This is the switch, right? Default gateway. Configure them in the configuration mode, right? Default. How to write the default gateway? I forget how to. What the instruction for default gateway? Let me just remember. Default gateway. IP default gateway. Yes, IP default gateway for the switch. We're talking about switch B, so this is the network. The interface on this router will be the default gateway, which was 128.107.30.1. Yes. Now let's check our progress. What is our progress? Yeah, it's 100%. That's it, finished. Okay. I hope this video have been informative, and thank you for watching, and good luck in the exam.